Hello friends, welcome to Learner's Planet. I welcome you to the second theory session for combustion and flame. In this session, we are going to discuss about flame. What is it? What are the different zones of flame? See, you must have seen the flames of candle, the flame of Bunsen burner. Bunsen burner you'll get in your chemistry lab. So we'll be discussing about this flame and also about the fire extinguisher. That is the methods to extinguish a fire. A fire may be caused by oil or due to the short circuit or due to the burning of any organic substance like wood or anything, or plastics get also burned. So we'll be discussing about methods to extinguish a fire. So let's start our discussion here. Flame, what is it? It is a zone of combustion of a combustible substance. Zone of combustion means where the reaction is taking place, where the compound is reacting with oxygen and is getting converted into carbon dioxide and water. Substances which vaporize during burning produce flames. Say for example, kerosene, wax. Even wax vaporizes on burning. So it produces flame. And substances which do not vaporize during burning do not produce flames, like coal, charcoal. You would have never seen the flame of coal. The substances which vaporize on burning produce the flame. See, this is the flame of a candle. Here wax is there. This wax vaporizes and produces this flame. This thing is made up of thread, which just carries the wax. The wax is heated up, it melts, and then it vaporizes. We can see different zones in this candle. See the lights. This is blue here. At the center there is black. Here it is yellow. So what is happening in this? What are the things which are taking place over here? Let's see it. How this combustion of wax candle takes place. First, I'll tell you about this. The wick burns and it stands in a pool of liquid wax. Suppose this is a candle. There, this is a wick. Right? Now, this wick burns. You lit this wick. What happens if you have seen the burning candle, if you have not, just observe it. You'll see there is a liquid pool of wax over here. Now within this liquid pool of wax, this wick is resting. There is a small portion of unburnt wick between the flame and the liquid wax. This one. The liquid wax is trapped in the cup of solid wax. This is just like it. It is trapped over here. The liquid or solid wax never catches fire. So this is not at all catching fire. Which is catching fire? The wick. The wick is burning, but not the liquid and the solid wax. So we can see that the wick is burning, but it cannot be only the substance that is burning, as the candle gets smaller as it burns. Have you observed it? The candle becomes smaller and smaller. That is, it is the wax vapors that burn. It is the wax that burns. The wax vapors that are burning, that are reacting with the oxygen of the atmosphere, and they are burning. If a lit match is brought a little above the candle wick, immediately after the candle has been blown out, the flame from the match jumps the gap and reignites the wick. This is because the wax vapors rise from the wick immediately after the candle is blown out, and the burning match reignites them. See, what is happening here is, this is the wick. If I am lightening this wick, the heat passes through this wick to the candle. Here the solid wax melts and it forms the liquid wax. This liquid wax is resting in the cup of this solid wax formed. This liquid wax travels up the wick and it vaporizes. It changes into its vapors. Once it has changed into its vapors, it reacts with oxygen. See your wax. Wax is also composed of the carbon compounds. Right? See, the carbon compounds are there, and this some CH, this will be there, and this will react with the oxygen, producing carbon dioxide and water. This wax is an organic compound, that is, it is a compound composed of carbon and oxygen. Carbon and hydrogen, I'm sorry. So it is composed of carbon and hydrogen. This burns, it means it reacts with oxygen, producing carbon dioxide and water, plus of energy. This energy is released in the form of this flame. That is heat and light. Now it is not the wick which is burning. Which is burning? It is the wax. Because see, as the candle is lit for a long time, what happens? The wax burns and it evaporates, and the candle becomes smaller and smaller. Now, to a blown candle, it is saying that if you are bringing a matchstick, it quickly catches up the fire. It quickly takes up the flame. Why? Because this vaporized wax is there on the wick. Wax vapors are present over here, which quickly catch the fire. So we can conclude that it is not the wick only which is burning. It is the wax which is burning. Right? This wick soaks or absorbs the molten wax. The heat of this flame vaporizes the molten wax. The wax vapors burn in flame. Got it? So in a candle flame, what burns? The wax. Wax vapors burn. Remember, it is the wax vapors which burn. Burn. And not the liquid wax or solid wax. Wax vapors are burning. It means wax vapors are reacting with oxygen, producing carbon dioxide and water and energy. This candle wick, what it does, it just soaks up the liquid wax. And here in the flame, it gets oxidized, or it gets vaporized and it reacts with oxygen. Got it? So this is how a candle flame is produced. Now there are different zones in the flame. I've told you that the wax is composed of organic compound which reacts with oxygen, producing carbon dioxide and water. Then how these different colors are there in the flame? See, this is the outermost part, which is blue in color. This is the outer zone, and this zone is the hottest zone, this blue one. It is the hottest zone. Here, the vapors are completely burnt, or complete combustion takes place here. Complete combustion takes place means here enough of oxygen is available. So complete combustion is taking place, and that is why it is giving a blue flame here. Right? That is the complete conversion of organic compound into carbon dioxide and water. And it is emitting less light. See your gas flame, that is also blue in color because there the complete combustion takes place. The central zone is the yellow zone. Here what is happening? It is less hot. And here what happens is here incomplete combustion takes place. Right? And in this zone, what is produced is, there is incomplete combustion. Why so? Because of insufficient oxygen. What all are the products here? Carbon monoxide plus carbon plus water. This carbon is given out as a soot. And this zone emits most of the light. Means say when the gas flame, it starts burning yellow, it means the oxygen supply is insufficient. The gas is not burning completely. The gas is not undergoing complete combustion. Right? Then as this is the inner zone. In the inner zone, see this zone is the coolest part of the flame. Right? Now in this zone, wax vapors remain unburnt as no oxygen is available. Here oxygen is not available. The innermost zone near the wick, the wax vapors are unavailable and hence, the oxygen is not available and hence the wax vapors are not burnt. And hence it is dark and emits no light. This is what is a candle flame. Got it? This is one of the more diagrams. This is the outermost zone of complete combustion, the middle zone, the innermost zone which is black. The hottest part is the outermost part because there the complete combustion is taking place. This is moderately hot and this is the least hot. See, this is also one of the explanation. The outer white zone is the non-luminous zone. Right? Then this zone. Oxygen supply is surplus and main reaction zone with water carbon dioxide. Zone 3 and 4. Complete oxidation of soot particles if temperature is over 1000 degrees centigrades and if temperature drops, oxidation ceases and soot is emitted. Then the luminous zone. Then the dark zone. Oxygen deficit zone. There the vaporized wax doesn't get oxidized. Blue emission due to chemiluminescence of excited CH radicals, oxygen surplus, paraffin wax burns here. Here you will find some blue vapors outside. Then there is a non-luminous zone and the liquid paraffin wax. Now what is luminous and what is non-luminous? A yellow flame is also called a luminous flame. Why? Because it emits a lot of light. So a flame which emits a lot of light is called as what? Luminous flame. A luminous flame is generally observed when there is insufficient oxygen. That is, incomplete combustion is taking place. In case of incomplete combustion, what are the products formed? The organic compound, plus of oxygen forming carbon monoxide plus carbon plus water. And this carbon comes out as a soot. Right? Its temperature is lower than that of the blue flame and it leaves behind black soot and other residues. A blue flame is also called non-luminous flame. Why? Because it is emitting very little light. A blue flame is generally observed when there is adequate amount of oxygen available. That is, ample amount of oxygen available. You can just see the gas burner. When the flame, when that flame is blue, it means there is, say, complete combustion of gas taking place over there. And when it starts coming yellow, it means that the pores, there are pores on this flame. The pores on this flame have been choked and it needs servicing and it needs to be cleansed up so that the oxygen supply or oxygen reaches the gas inside. And a flame does not show uniform color. Obviously, there are different zones in a flame. So this is what a flame is. Now students, when there is a flame, it gives you light and it also can be used. But if it goes uncontrolled, that is, if this candle falls over some wood or if there is a cloth, if it falls on it, then it will catch fire. And fire is dangerous. So we need to control that fire. Now let's see how a fire can be extinguished. The ways to extinguish fire. Before telling you about the extinguishing of a fire, I'd like to tell you the change in color of flame with the increase in oxygen supply. See, this is a Bunsen burner flame, and the color of the flame here depends upon the oxygen available, right? So the color of the flame depends on the temperature and amount of air available, and the nature of the substance burning, also what you are burning over there. See, hydrocarbons burn with blue or yellow flame. Now here, see, with the increasing oxygen supply, this is incomplete combustion. In this case here, the combustion is complete, whereas rest of them, the combustion is incomplete. In this case also, the combustion it's complete till here. And in this case, the combustion is complete throughout the flame. So that is, when the oxygen supply is increased, the color of flame changes. So the color depends upon how much oxygen is available, and also obviously the extent of combustion depends upon the availability of oxygen. So more is the oxygen available, complete is the combustion. And if the combustion is complete, the color of that flame becomes blue, and it is the hottest, and also it will emit less light. Now let's see how we can extinguish a fire. See, a fire can be caused by oil, by say petrol or kerosene or any other oil, that is called as a liquid fire, or it can be caused due to the short circuit, that is the electrical fire, or you can burn a wood or a paper. So there are different methods to extinguish different types of fire. Like in fire caused by oils or the liquid fire, you can't use water. So let's see how to extinguish these different types of fire. The essential conditions of combustion are fuel, air and heat. We have seen this. What is the essential condition? First of all, you need a substance which can react with oxygen and release energy. That is called as combustible substance or fuel. You need air because the reaction is with oxygen. And of course, a small amount of heat is required to raise the temperature so that the reaction can start, or to raise the temperature of the fuel beyond the ignition temperature. What is ignition temperature? It is the minimum temperature at which a substance gets burnt or catches fire. This fire can be controlled by removing one or more of these requirements. Now, if you are talking of extinguishing a fire, it means one of these required things are to be removed. So once there is a fire, you can't cut up this heat. See, this is the heat is required so that the substance starts burning, so that the temperature of the substance increases beyond the ignition temperature. Fuel, of course, is there, you can't remove it. But air, you can cut this oxygen supply. This is what the principle used by fire extinguishers. We can cut this oxygen supply. Fire can be controlled by removing one or more of these requirements. See, water is used for extinguishing fires. Fire caused by wood, fires caused in jungles, fires caused in your houses, in houses. Water is used. Why? Because say water, when we just throw water on the fire, what happens? The water evaporates. Right? This water, which is in the liquid state, it changes into its vapor state. When it is changing into its vapor state, it is absorbing heat. Obviously, without absorbing heat, it cannot change into its vapor state. So it is absorbing heat from the fire, as a result of which it cools down the burning material, and that too below its ignition temperature. Right? Say if there is a fire caused due to wood and water is splashed on it, what will happen? Say water will absorb heat and will evaporate. While changing into the vapor form, it will absorb heat, right? So that is, it is cooling that burning substance. It is cooling that wood. and that it cools down the wood and thus decreasing the ignition temperature, or thus decreasing the temperature below the ignition temperature. That can be done, right? But use of water can't be done everywhere. It can be dangerous also. Water should never be thrown on a liquid fire. Say if the fire is caused due to petrol or kerosene. Now in this case, this water doesn't mix with oil, and water has got a higher density. The oil floats over water, or you can say the oil has got a lesser density. So what will happen? In this case, water will not mix with oil, and also water is heavier. So water will settle down. Say if there is a petrol spilled over here and it has caught fire. Now if I'm putting some water in this, so what will happen? Water doesn't mix with oil. Water doesn't mix with oil. Secondly, water is heavier than oil. So what will happen? See here, the water will settle down. Water will settle down over here. And oil will keep on burning. Right? In this way, what will happen? The temperature of water will also rise. Water will vaporize and become steam quickly. Now, since water is at the bottom of oil, as it evaporates, it sprays hot burning oil in all directions, or in every direction. This then spreads the fire. Got my point? So what is happening basically? Say if there is a fire due to kerosene or petrol or any other oil or diesel, it should not be one should not try to extinguish this fire with the help of water or with water, because when water is splashed over it, what happens? Water and oil being immiscible, that is, they do not mix with each other, and also water being heavier, settles at the bottom. This oil burns, keeps on burning, the water evaporates, and oil, it is burning also, and steam is coming. Now water is at the bottom of the oil. So this steam sprays oil in every direction and thus making it more dangerous. In that case, fire extinguishers are used. In this case, that principle is not working, that water evaporates, thus cooling down and decreasing the temperature below the ignition temperature. This thing is not working as water is beneath. Right? Secondly, water should not be used over electrical fires. Say if the fire is due to a short circuit and water is sprayed on or water is splashed on it. Now water, of course, it is impure. 100% pure water is not available. So impure, and this will conduct electricity. Right? This will conduct electricity. Now the person who is splashing water on the fire will get electric shocks. The first thing to extinguish an electrical fire is to turn all the power to off. And you can't go to each and every switch and switch it off. Just go to the main power and turn it off. This step alone is usually enough to stop fires in initial stages. But if it has caught, the fire has become uncontrolled, the safest and the best way to extinguish an electric fire is to use fire extinguisher. Again, this fire extinguisher is used, and use of water is dangerous here. Now, what are fire extinguishers and how they work? Fire extinguishers make use of carbon dioxide gas, as it is not a supporter of combustion. Carbon dioxide stops the combustion. Being heavier than air, carbon dioxide settles down and cuts off the supply of oxygen, which extinguishes the fire. This is a fire cost. If carbon dioxide is sprayed on this fire, or if the fire extinguisher is used, what happens? This carbon dioxide forms a film or a blanket over this fire. It is heavier than air, and also it is a non-supporter of combustion. So in this case, a carbon dioxide gas will form a blanket over here. By forming this blanket, what is it doing? It is cutting off the supply of oxygen. And combustion or fire or burning, that is due to the reaction of the substance with oxygen. So this combustion is due to the reaction of the substance with oxygen. Now, after using fire extinguisher, what has happened? That a blanket of carbon dioxide is formed, which has cut the supply of oxygen, and so there will be no combustion reaction. No combustion reaction, no fire, and the fire will be extinguished. There are two common types of fire extinguishers. These are carbon dioxide fire extinguisher and soda acid fire extinguisher. You must have seen this fire extinguisher. It consists of either the carbon dioxide gas in it or soda and acid. Soda, that is not your that is a different soda. It is sodium bicarbonate, not that soda which you drink. So it is sodium bicarbonate. How it is used? Just hold extinguisher upright and pull the ring. That is safety pin. You have to just pull it. Stand back from the fire and aim at the base of the fire nearest to you. You have to aim at the base. Squeeze handle together and sweep the extinguisher stream side to side. You have to squeeze this side to side. These are simple words: pass, pull, aim, squeeze and sweep. This is pass. You have to pull, pass on, give it to somebody, pull, then aim, then squeeze and then sweep from side to side, so that carbon dioxide is evenly spread over the fire. A carbon dioxide fire extinguisher, it consists of carbon dioxide filled under high pressure in cylinders. Say when you pull it, when you just open the safety pin and pull it, open the safety pin, the pressure is released. When the pressure is, say the cylinder is having a high pressure inside. When the pressure is reduced, the gas comes out. Carbon dioxide fire extinguishers are filled with non-flammable carbon dioxide gas under extreme pressure, that is under high pressure. The pressure in the cylinder is so high that when you use one of these extinguishers, bits of dry ice may shoot out the horn. That's bits of dry ice means solidified carbon dioxide. The pressure is so high that the carbon dioxide has turned to solid. Right? So bits of solid dry ice is solid carbon dioxide. Within the cylinders, the pressure is so high that some of the carbon dioxide has changed to its solid state. Remember, when the pressure increases, the volume decreases, and the least volume is of the solid state. Carbon dioxide fire extinguishers are useful for flammable liquid and electrical fires only. Carbon dioxide extinguishes fire by forming a blanket over fire, thus cutting off the supply of oxygen. Now carbon dioxide is coming out as dry ice also, and it is extremely cold. It is extremely cold, I tell you. Solid carbon dioxide. The carbon dioxide is very cold, and as it comes out of the extinguisher, so it cools the fuel as well. It is very, very cold. Say ice is cold, right? As soon as it falls on the fire, it also cools down the fuel. It also lowers the temperature of the fuel below the ignition temperature. Carbon dioxide fire extinguisher may be ineffective in extinguishing Class A fires. What are Class A fires? The fires caused by paper, wood, cardboard and plastics, because they may not be able to displace enough oxygen to successfully put out the fire. So these materials, they also reignite. But this is very, very helpful in extinguishing liquid fires and also the electrical fires, right? Carbon dioxide basically works on the principle of cutting off the oxygen supply to the fire, and thus it extinguishes it. And also say it is the carbon dioxide is stored at high pressure, very, very high pressure inside the cylinder. So carbon dioxide ice, so solid ice, is also shooted out, which falls on the fuel and thus lowers the temperature below the ignition temperature, which is the minimum temperature at which the substance catches fire or burns. The next type of fire extinguisher is soda acid fire extinguisher. This type of fire extinguisher contains concentrated solution of sodium hydrogen carbonate and sulfuric acid in separate compartments. When these mix together, carbon dioxide is formed. It is releasing carbon dioxide only. But in carbon dioxide type fire extinguisher, carbon dioxide is filled at extremely high pressure within the cylinder, and in this type of fire extinguisher, sodium hydrogen carbonate and sulfuric acid are taken in separate compartments. As soon as the lid is pulled, the reaction takes place and the two substances, that is sodium hydrogen carbonate, which is NaHCO3, and sulfuric acid, that is H2SO4. They react and they form sodium sulfate, Na2SO4, and carbon dioxide and water. So this carbon dioxide is just sprayed from the cylinder, thus extinguishing a fire. So this is how, students, a fire can be extinguished. And above all, if there is a fire, one should not panic, because in panic one always takes a wrong decision. You should not panic and just try to, if there is an electric fire, just switch off the main switches, the main power source, and never put water in case of electric fires or the liquid fires caused by kerosene or petrol. And in case there is a fire due to wood or something else, we can extinguish it by water. So this is all about this session, students. I hope you have enjoyed this session and also understood. This is a very basic thing. The fire, extinguishing a fire, it's a very important thing also. Everybody should know what actions to be taken if there is a fire. Now I'll be concluding this session, students. In the next session, we'll be discussing about fuels. Thank you, students, for listening patiently. I hope you have enjoyed as well as understood. We'll be meeting in the next session and we'll be discussing about fuels and also about the type of fuels. Thank you once again and do have a nice time ahead.